We're going to look at the molecular orbital energy level diagram for the He2 molecule, dihelium, and we're going to see why it doesn't exist. But it's also known that the helium, the dihelium ion with a +1 charge does exist. This is not explained well by any of the other theories we've looked at in class, but molecular orbital theory does explain it quite well. So we're going to have our two heliums, one here on the left and one on the right, and when they bond, they're going to form bonding orbitals and antibonding orbitals. The bonding orbitals will be at a lower energy, and the antibonding orbitals will be at a higher energy. If we end up with two on each of those levels, they will cancel each other out. So this is the 1s atomic orbital. This is going to be the sigma 1s, it's a sigma bond, molecular orbital. Up on top here would be sigma 1s star molecular orbital. So down here we've got a bonding orbital, and right here we have an antibonding orbital. So we're going to go ahead and put our two electrons in the helium 1s orbitals, and then we're going to put one down in the bonding orbital from the helium on the left, and then one down here from the helium on the right. That leaves us with two more electrons, and those both go in the antibonding. So if we were going to look at the bond order, the bond order is 1/2 the amount of bonding electrons minus antibonding electrons. So we have two bonding electrons and two antibonding electrons. So we see the bond order equals 0. So no bond, helium-2 or dihelium does not exist. It's never been detected to exist. Well, interestingly, the dihelium ion has been found to exist, and it is explained to exist by molecular orbital theory. So on the left, we have a helium with a +1 charge. It's lost an electron. On the right, we're going to have a normal neutral helium atom. We're going to fill up the bonding orbitals first because they're lower energy. They're going to fill up first when these two overlap. So we get a sigma 1s electron from the helium ion on the left, and then one from the right. Now there's only one electron left over to put into the antibonding orbital. So you can see that they're not going to cancel each other out. The bond order is going to be 1/2 the bonding electrons, which is 2, minus the 1 electron we have up here that is antibonding. So we end up with a bond order of 1/2. That's 1/2 of a bond. Now it's not a super strong bond, and I'm not telling you that He2 +1 is extremely stable, but it has been known to exist for a particular amount of time. And so using molecular orbital theory, it explains the existence of ions or molecules that the other theories do not.